All right, everyone, let's go ahead and do this. This is chapter 9, homework number 6, right? So we're going to be doing number 70, graph the system of inequalities below, right? So this is the first one. I'm going to put that in red. This is y is greater than or equal to 2x minus 4, right? So I'm going to go ahead and start graphing that. I'm going to start with the minus 4 because that is my y-intercept. So it's going to start down there. And now I need my second point, which is found by using my slope, which is going to be 2. But you can, to make it a rise and a run, you're going to make it into a fraction. So it's going to be 2 over 1, which means I'm going to rise 2 and run 1, right? And then I can go ahead and utilize some rulers or a line or whatever. I can freehand it if I want, but I'm going to go ahead and graph that. So I'm going to draw a line. Maybe like that. And looking at my inequality, it looks like it's a equal to, because there's a little underline right there. So I'm going to go ahead and draw my line solid. Okay, move this aside. And then I'm going to go ahead, and if I don't really know how to read this, I can go ahead and just take a test point and test it. So I'm going to use the 0, 0. So really I'm going to put a 0 right here, and I'm going to put a 0 right here. So if I copy it, I'll get 0 greater than or equal to, and 0 times 2 is 2. Sorry, 0 times 2 is 0. Take away 4, and that makes 0 is greater than or equal to negative 4. And that is true, so I would shade towards the 0, 0. Okay, and if you know how to read this thing with a greater than or less than symbol, then you can actually get the shading correct as well. Okay, but if you're not too sure, I would suggest you taking the test point and then shading on the same side if it's true, or shading on the opposite side if it's false. In this case, 0 is bigger or greater than negative 4. This is true. The next equation, put that in blue. This is y less than x, and then that's, if you don't see anything else, it's plus 0, which means I'm going to start at 0, 0, or 0 on the y, and then again I'm going to use my slope. That's 1, and I'm going to make it a fraction, 1 over 1, so it's going to go up 1 and over 1. So it's going to look something like this. Again, I'm going to go ahead and use my ruler. So it's going to roughly look like that right there. I'm just going to go ahead and draw in my... Actually, if this was a up 1 over 1, it should be a 45 degree. That's what I was trying to get at right here. Okay, I think I'm done with that. Okay. Oh, and this one is... Oh, let me redo that. This one is going to be a dotted line. So I'm going to go ahead and draw my line, and it's going to be dotted or dash. Oh, kind of messed that one up. All right, that's fine though. That's still pretty good for having a ruler but not using it. So that's going to be my dash line. And then again, if you understand how to read this inequality, you can go ahead and read that. But if you don't understand, and notice how this goes through the point 0, 0, which means I can't use 0, 0 to check, right? But I can use any other point that I may feel comfortable with. For example, I can use, I don't know, 0, 1, which is right here. Okay, so if I use 0 for x and 1 for y, and then just, I need to check this out. Is 1 smaller than, or was 1 less than 0? That's false. So that means I wouldn't shade towards that point. I would shade away from it. So I would shade everything over here. Okay. And our solution is just that region where you see red and blue, right? And 0, 0, that is not part of the solution because that goes through the line and the line is dotted, which means that it's not actually counting the line, right? So our shaded region is actually this part right here, which I have in black. So all of this right here. So we see the red and the blue. And normally I just leave it alone, but you know what? Just for you guys and just because this homework assignment calls for shading in the region. Yeah. And it gets bigger and bigger. So it just kind of keeps getting bigger and bigger and bigger. So it just keeps getting wider and wider. So it's all of that right there. Okay. But that's all I'm going to do. Write and solve an inequality for this situation. Okay. So honor 50 years in business, all Strikes Bowling will have their anniversary special. Shoe rentals for $1.25 and each game is 75 cents. If Charlie has $20 and needs to rent shoes, how many games can he bowl? Right. So let's think about this. Charlie has $20. So the most he has, or you can say it's equal to $20, right? But that's the most he has. So $20 is the most. So that means that the alligator mouse should be eating the 20. Okay. Everything else that he spends should be less than 20.
Marvin Martinez, please report to the office. Marvin Martinez, please report to the office.
It's going to cost 75 cents for every game, and then it's also going to cost $1.25 for shoes. So that's your inequality, right? So how many games can Charlie bowl? Well, you have to kind of figure this out, right? I'd say let's subtract 125. He's going to go away. You're going to get 0.75x less than or equal to, and $20 minus $1.25. $20 minus $1 is $19, and then minus 25 cents is $18.75. Right, and if you need a calculator, looky, I got one here. Okay, so you can go 20 minus $1.25. So there it is, $18.75. Now I'm going to need a calculator because I need to figure out, you know what, how many of these 75 cents goes into the $18.75. Right, by doing that, I will solve for my x. So x has to be less than or equal to, and x is the number of games that he can bowl. So 1875 divided by 0.75. So he can bowl 25 games. Right? So I'm going to write Charlie can bowl 25 games. Okay, solve the system equation at the right. This is something we did before we left for Christmas break. Looks like this is set up in, because the x's are lined up on top of each other and the y, ooh, no way. I got to fix the bottom part, but it looks like they're going to be lined up on top of each other if I just fix it. So I think I'm going to go ahead and do elimination method, right? You can do substitution as well, but I'm going to go ahead and do elimination. So I'm going to go ahead and copy the top equation down. So 2x minus 3y equals 12. And the bottom equation is x plus y equals negative 9. I switched x and y around. And because these are both lined up on top of each other, for example, the x's are good and the y's are good too, right? So I can pretty much just leave them the way they are. But I do need to get rid of one of the variables, x's or y. So I think I'm going to multiply the bottom equation. And I want to get rid of the y, so I'm going to multiply the bottom equation by 3. Okay? So let's check it out and see what happens, right? So I'm going to have 2x minus 3y equals 12. And the bottom equation is now, so the top equation, I didn't really do anything with it. But the bottom equation is now, so 3 times x is going to be 3x. Okay, I can't do anything with that, but check out what happens. 3 times y is positive 3y, and I'm going to be able to cancel those y's out. And 3 times negative 9 is negative 27. Right, so that's what I'm going to work on. And I'm going to go ahead and cancel these negative 3y and positive 3y. That's going to leave me with 5x equals, and 12 minus 27, negative 15. Okay, and then I'm going to go ahead and divide it by 5. These are going to cancel. And I get x equals negative 3. So here's my answer, or part of my answer. So if x is negative 3, what's y? Well, I can use any of my equations, but I think I'm going to use this bottom equation. And I'm going to rewrite it as, I'm going to take away the x to the other side. Okay, those go away. So I'm going to have y is equal to negative 9 minus x. And I'm going to go ahead and put a negative 3 in place of the x, because that's what it says right here. X is negative 3. So I'm going to put negative 3 in place of the x. So my y is going to be negative 9, and I have a negative 3 is a positive 3. So y is equal to negative 9 plus 3, which is going to come out to be negative 6. So my y value is going to be negative 6. And that's my answer for number 73. Okay, 75, solve the following equations for x. All right, so letter A, 4x minus 6y equals 20. And if I'm solving for x, that means I need to get everything away from the x. So I need to start off with adding 6y. And I'm going to go ahead and leave the variables in the front, if you don't mind. So I'm going to have 4x, copy it down, equals 6y. And like I said, I'm going to leave the variable in the front, plus 20. Okay, and then I'm going to finish it off by dividing by 4, which means everything gets divided by 4. Okay, and that's going to cancel. So I will have x equals, 6 divided by 4. You can't really do that. So I'm going to go ahead and reduce it a little bit. Divide both of these by 2. And 6 divided by 2 is going to give me 3y. 4 divided by 2 is 2. So it's going to be 3 halves y. Plus, and 20 divided by 4 is going to be 5. So that's what my answer is for x. Okay, B. I have 1/2 x minus 6 equals 9. Okay, I'm going to go ahead and solve for x. Okay, this one doesn't look like it has another variable, so it's going to be just x equals. Okay, so it looks like I'm going to go ahead, and most of you guys might want to do this, distribute this, but I'm actually going to do something a little different. Okay, I'm going to get rid of the 1/2. So to get rid of 1/2, I'm going to multiply it by 2 over 1. If I do to that side, I'm going to have to do to this side. That's going to cancel the 2's out. So I would just be left with x minus 6. And 9 times 2 is 18. So that way I keep whole numbers. And actually, I don't even need the parentheses for x minus 6. Right? And then I just got to finish it off by adding 6. Those will cancel. And we get x equals, so 18 plus 6, 24. Okay, that's my next answer. Okay, C, 4/5 plus 18 over x equals 8. Again, it looks like it only has one variable, the x, so that means I can actually solve for it, find out exactly what it is. Unlike letter A, which has a y, and I couldn't really solve for the whole answer. I couldn't get answers in terms of y. Wow, this one looks tough, but especially if you don't like fractions. I'm going to go ahead and subtract 4/5. So 8 minus 4/5. Okay, these are going to go away. So I get 18 over x is my answer on that side. And I have to figure out what 8 minus 4/5 is. Okay, I can show you by hand, but I think this is a little too much for some of you guys. So utilize the calculator if you want. 8 minus 4/5. That's 7.2, right? And if I know a lot of you guys will be happy going to decimals, but I kind of like fractions, and 7.2 is actually 36 over 5. Okay, so I'm going to leave this as 36 over 5. Okay, almost done. Because you notice how x is on the bottom, I can actually flip both sides of the fraction. So I can have x on top and 18 on the bottom. And because I do that, I have to flip the other side of the fraction as well. So I will have 5 on top and 36 on the bottom. And by doing that, I can now go ahead and multiply it by 18 on both sides. Okay, this is going to cancel, and I will have x equals. And the 18 and 36, those are actually going to cancel also. Okay, 18 goes into 36 twice. So my final answer is 5 over 2. Okay, last one. D. What the heck is going on here? D. 2 plus absolute value 2x minus 3. Absolute value close equals 5. Now, when you see something like this, you don't automatically start working on the absolute value. Okay, you want the absolute value to be by itself, to be isolated on one side before you can write the two equations down. But you need to get rid of that 2 first. So I'm going to go ahead and subtract 2 from both sides. By doing that, I will now have just absolute value of 2x minus 3 equals, and 5 minus 2 is 3. And now I can go ahead and do a positive version of it, which is going to be 2x minus 3 equals 3. Copy it just the way it is, and then negative version of it, because we all know that the absolute value, the distance away from 0, for it to be 3, you could have a value of 3, or you can have a value of negative 3. So for the total distance to be 3, you can have it at 3, or you can have it at negative 3. And that's why we have to do two equations. Okay, but that 2x minus 3 is going to equal negative 3, or 2x minus 3 is equal positive 3. Okay, I'm going to go ahead and do all this at once. So I'm going to go ahead and add 3, because that's the inverse operation. And I'm actually going to do the same thing here, add 3. I'm going to kill 2 birds with one stone. Okay, but please don't kill birds. Okay, so cross all those 3's because those are opposites. But 2x equals, and then negative 3, positive 3 makes 0. Okay, over here, copy down 2x. This one's going to be positive 3, and positive 3 makes 6. Okay, and then now you're going to go ahead and inverse the 2, which is the times 2, which is division by 2. And you're going to do the same thing here, division by 2. Okay, we're going to cross off the 2's for all of these and just copy down the x. 0 divided by 2 is 0. That's one of your